Alright, so in this math counts preparation video, we're going to be talking about modular arithmetic. Right, so modular arithmetic is a very useful tool. It helps you get to the answer in a lot of problems way faster. And as we're going to see in the problem today, there's two ways of doing the problem that we have today. There's a slow way and then there's a fast way. The fast way is, you guessed it, modular arithmetic. So learning modular arithmetic, it really doesn't take that much time, and once you do a lot of practice problems, it's not that hard anymore. So let's get into it. So we're going to start off with basically, if I just say that, let's try taking mods of certain numbers. So basically, if I have 9 and I take mod 7, so 9 mod 7 is basically just saying, what is the remainder when I do 9 divided by 7, right? When I do 9 divided by 7, I'm going to get some fractional result, right? But 9 is 2 more than a multiple of 7, right? And 14 is too big, so 9 mod 7 is basically just 2, right? So I can now say that 9, we say, is congruent to 2 in mod 7. And this concept of congruence is basically a lot of modular arithmetic. Here we're saying that 9 leaves the same remainder as 2 when divided by 7. 2 mod 7 is just equal to 2. And 9 mod 7 is also, it's 2. And we say 9 is congruent to 2 mod 7. Don't say equal 9 is congruent. We use this congruent symbol over here. 9 is congruent to 2 mod 7. That's what we say. And that's basically, it'll take some time because at first it just seems a lot, but let's just do some practice. So let's do practice. So let's use mod 2. Let's just use mod 2. So if we're checking out mod 2, so then let's see what we have. So basically mod 2, let's see what we can find in mod 2. So mod 2, well, let's just see, or we can just work in mod 7. Right, let's just find a mod. So let's see, what's 7 mod 2? So I'm going to throw out an example. What's 7 mod 2? 7 mod 2 is you just do 7 divided by 2, and 2 times 3 is 6, so it's 1 more than a multiple of 2, so this should give us 1. So we can now say that 7 is congruent to, let's see, so 2 times 3 is 6, 2 times 2 is 4, okay, so we can say that 5 is congruent to 7, is congruent to 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, is congruent to 9, 2 times 5 is 10, is congruent to 11, is congruent to 13, all in mod 2. The reason these are all true is when you divide 7 by 2, you get the same remainder as if I do this by 2 or this by 2 or this by 2. So that's basically what we're doing here. So that's basically the basics of modular arithmetic. Now let's go on to the actual properties. So properties and slash formulas, I'm not sure, whatever you want to call them, but these are the useful things. These are the useful parts of modular arithmetic. First off, let's say we know that A is congruent to X in mod M, and we also know that B is congruent to Y in mod M. Then we know that AB, the product AB, is congruent to XY in mod m. And this is a very useful property. So basically, let's just see what we can find. So I'm going to do an example. So 5 is congruent to 7 in mod 2. So 5 is congruent to 7 in mod 2. These are congruent. And then since we know this, since when I divide 5 by 2, I get a remainder of 1, and I do 7 by 2, I get a remainder of 1. And then I also say that, what else can we say? Well, we can start off with 9 is congruent to, in mod 2, of course, we're doing in mod 2. So 9 is congruent to 11 mod 2. We need the same modulo, so mod m, and this is remaining the same, so it's mod 2 here. So we've just replaced m with 2 here. So when divided by 2, 2 times 4 is 8, 5, okay. So this congruence is true, and with our property here says that we can just multiply these, and then this congruence will still hold true. So we multiply these. 5 times 9 is 45, is congruent to 7 times 11 is 77 in mod 2. And you can just see 45 is one more than a multiple of 2. 77 is also one more than a multiple of 2. And if we divide this out, we should get the same remainder of 1. So that's basically a good property. Another property. So property is continued. So this one's actually one of the more useful properties, but if we say that a is congruent to x in mod m, then we can say that a to the n is congruent to x to the n in mod m. And this is one of the more useful properties. This one's also very useful, but this one you find more often in problems. So a is congruent to x in mod m, and a to the n is congruent to x to the n in mod m. So basically, let's just use an example. This time I'm going to switch to mod. We're going to do mod 3. So in mod 3, let's do 5 is congruent to what? So 5 mod 3 is just, so 5 mod 3 is basically, if I just do 5 divided by 3, I should get a remainder of 2. Yeah, so I get a remainder of 2 after I do that. I get a remainder of 2, and I get a remainder of 2, so now I can find a congruence, right? I can find a congruence. So 5 mod 3 is 2, so then 5 mod 3 is 2, so this is the same as 2 in mod 3, right? This is the same thing. 5 mod 3, like 2 mod 3 is equivalent, 2 mod 3 is equal to 2. So no, never mind. This is not congruent. So erase that. We need another one. 5 is congruent to what? Mod 3. Okay, so 5 is 2 more than a multiple of 3. So 3 times 2 is 6. So 6 plus 2 is 8. So 8 mod 3. This is an actual congruence, since 8 divided by 3. 3, 8, 2s are 6. Same remainder. So if I have this, then I have this right here. A is congruent to x in mod m. So then I can just raise these both to the same power. So I'm going to square both of them. So I have 5 squared is congruent to 8 squared in mod 3, not mod m. And this means that 25 is congruent to 64 in mod 3. And each of these should hold true because we are doing it the same thing. Yep, so the congruence is true. So this congruence must hold true. You can go ahead and check it with the division. So 25 is congruent to 64 in mod 3. So those are the properties you need to know. I mean, we can go ahead and practice. Go ahead and practice. So basically, by practicing, let's say I want to find the remainder when 16 times 27 is divided by, I don't know, 3? No. 16 times 19 is divided by 3. I don't know, I'm just making stuff up. So 16 times 9, I'm going to make the 16 to a 17. So, I mean, I guess you can go ahead and practice with that. Yeah, so 17 times 19. So, if we have 17 is congruent to what in mod 3? So 17 divided by 3, we can just do the division, is 2. So this gives me 2 mod 3, which is, yeah, that's true. So 17, so this congruence is true. This congruence is true, and also that congruence is true. So when I said that was actually true, I didn't realize it was true. So 19 is congruent to what in mod 3? So now we should do the same thing for 19. So in mod 3, I mean, we can just go ahead and do the division once again. Oh, 1. 19 is congruent to 1 mod 3. So we can go ahead and just do that. So, and we know we can just multiply them. So 17 times 19 is congruent to 2 times 1 is 2 mod 3. And now 17 times 19, all we need to do is find 2 mod 3. That's all we need to find. And this is just 2, so the remainder is 2 when you do that. And you can go ahead and multiply it out and check, but I'm not going to because modular arithmetic gives us answers so fast in remainder problems. So let's move on to the problem. Alright, so what is the remainder when 2019 to the 2019 is divided by 2020? So, I mean, they do this every year. They have like problems centered around the year. This is the 2019 school sprint. School sprint. Now, it's a school sprint. Most people are going to go ahead and they're going to go like, let's try to find a pattern. And this is what I actually did before I knew modular arithmetic. This was like a couple of months back. So, a couple of months back when we were doing these. So, 2019 to the 2019 is divided by 2020. A couple of months back, I didn't know what modular arithmetic was. And I went ahead and found a pattern, and it took 10 minutes. On the sprint round, you don't get 10 minutes per problem. So, we're going to use modular arithmetic. I know how to use modular arithmetic. So, let's use modular arithmetic. So, what is the remainder when 2019 to the 2019 is divided by 2020? So, there's, as I said, 2 ways in the beginning of the video. I said there's 2 ways to solve this problem. One is we can make a long list and find patterns and eventually look at the answer in like 5 to 10 minutes. Or we can do it the quick way. I like the quick way. Let's do it the quick way. Quick way. So first I'm going to make things a little bit easier. I'm going to write this out. See what I'm trying to do. Okay, now whenever I have an exponent on the top, I like to take the mod of the base. So basically, I'll do 2019 is congruent to -1 mod 2020. Now, note that negatives can be mod, so I can have a negative mod, and this basically means that 2019 is one less than a multiple of 2020. Remainders can be negative, realize that. So this is a remainder of -1, so this is one less than a multiple of 2019. So this is why you have one less, -1. So this congruence is true. This congruence is true because -1 mod 2020, so 2019 is one less than a multiple of 2020. That multiple of 2020 is 2020 itself, since 2020 multiplied by 1 is 2020. So that's what we're doing. And we want the remainder when 2019 raised to the 2019th power. This is why I take the mod of the base. I like to find a congruence. And now we can raise this to the 2019th power. That's pretty easy. Of course, we're not going to multiply it out. And this is congruent to -1 to the 2019th. And it's in mod 2020. So now the only thing we have to do is we just have to find -1 to the 2019. So -1 to the 2019, 2019 is an odd number. So any power of -1 that's odd results in -1 again, and any even power, such as 2, -1 squared is obviously 1. So any even power results in 1 because you pair in groups of 2, but you can't pair an odd number in groups of 2 all the way without having a remainder of 1. So this is -1. So we have 2019 to the 2019 is congruent to -1 in mod 2020. And now we can find -1 mod 2020. So whenever you have a -1 and then you have a mod, you just subtract, you find the difference, the positive. So 2020 minus 1 is 2019. So -1 mod 2020 is just 2020 minus 1, which gives us 2019. Which is the remainder. So the other way would give us the same answer, but it would take forever. It would take literally forever. And now we have a fast answer with modular arithmetic. So, and we use the property. We again use our property that if a is congruent to x in modulo m, then a to the n is congruent to x to the n in modulo m. And again, I made a mistake in the video, so if you see that 17 is congruent to 2 mod 3. So that's because when I do 17 divided by 3, I get a remainder of 2, and 2 mod 3 is also 2. So yeah, that's how modular arithmetic works. So yeah, that's modular arithmetic. It made this problem like 10 times easier. Otherwise, these big numbers, who's going to multiply this, divide, or find a pattern? Finding a pattern also seems scary in this problem because there's big numbers. So yeah.